Hello, my name is Arjun Suri, and today I'll be presenting my team's project, which is for diagnosis. So I've compressed all of our design thinking stages into this PPT, and then I'll be going through our idea or actual prototype. So yeah, the problem that we narrowed down to was basically split into two. It was deciding whether a skin lesion is harmful or not, and this is often regarded as trivial, but it's something that causes a lot of stress, a lot of anxiety among people. When they see a skin lesion, they don't know what it is. So, A, we wanted to help them discern whether it's harmful or not. And B, we wanted to help diagnose, while doing so, diagnose skin cancer because skin cancer is a disease which basically can be quite curable, unlike a lot of cancers in early stages if it is found early enough. So, yeah, that's basically we plan to do. And so currently the system in place is quite inefficient because in a lot of stages, in most stages of the system, uh, a lot of time is consumed. So this can lead to a lot of stress because people are often left in anticipation of whether this is harmful or not, whether it is when they first observe it uh, to the time when they are in the hospital trying to get a proper diagnosis. uh, the system in place takes a lot of time. It has a lot of stigma and stress involved. So that's what we are targeting. We want to create a desired system where we basically help reduce this gap, and as a result, we arrived at our solution, which is an online network-based diagnosis system. So we did not consider any environmental consequences while deriving a solution, but we consider these four uh, basically criterions listed on the slide because uh, when we are talking about environmental consequences, we didn't think it would be too applicable to our project because we had decided that we wanted our project to be digital so that it's accessible to almost everyone who owns a smart device. So while ideating, we narrowed down our ideas to two ideas in network and a CNN, a convolution network, and as they're practically the same except a few layers of neurons, uh, few layers of convolution. The main deciding factor between them was the data set to be used, not factors such as economic, social, and financial factors. So the data set we used was quite a large data set of the ham 10,000, and as a result, we went with using neural networks. So we basically plan to make this on a website. So we had a front end back end structure and neural network architecture. Uh, so we aren't completely done with scaling our website yet, but we have made a neural network. And currently our website runs on Django, but in the future we are looking to basically change it to Flask. So yeah, this is what our front end would probably look like. Again, it's in its rudimentary stages, so yeah, it's pretty uh, rudimentary. So yeah, we're planning to basically have this feature where you can choose a file which would be a image of a skin lesion you click, and then initiate diagnosis. And we have our basically model over here. So we have a lot of layers and a lot of neurons, as you can see, like 10,000 neurons because of how large our data set is. So yeah, we have made both a model and a website, but the problem that arises right now is that a model, while it has no loss, it is very efficient in terms of loss. It is a little compromised in terms of accuracy. So, as a result, what we're planning to do right now is we are planning to basically probably we have actually changed a lot of metrics to our model, and we might have to actually go back to a convolution neural network instead of a normal neural network because right now what we did was we were slightly overwhelmed by the sheer amount of images in our data set. So we converted them all to pixel values and we treated those pixel values, but Now, since our model is inaccurate, we think that our decision to go with a neural network is kind of misfound because it's not able to detect edges and specific contours. So yeah, I think a CNN would be better, and so does our team. And furthermore, in terms of our reflection, uh, we also think that in our model, while we did train it with a lot of data from the same data set, it had 10,000 images. We need to diversify our data set a bit more and take like real world images to train our model. And we also have to, something we are looking at was also including not just this self-diagnostic kit, but also adding some content, some advisory to while to inform users that while they can treat this website as a quite reliable source of diagnosis, they should still consult with a medical practitioner. And yeah, while we would be diagnosing vascular lesions specifically, which are not harmful, we'd still recommend that they get it checked just in case. But it does give a peace of mind to users, so that's why we thought that we would include it in our diagnosis system. So yeah, before the exhibition, if we selected, our plan is currently to uh, change our neural network to a CNN based on our current reflections so that our model can be much more accurate and also beautify our front end a bit more. Thank you.